Okay, chemistry students at Borger High School, now we have the 5th installment of the chemistry of physical properties and chemical properties. So we have Unit 3, Matter and Change. So we're on Roman numeral number 4 in your notes. Starts on page 5 in your notes, and we're talking about extensive and intensive properties. And we've already talked about this when we did your mind map. We started a mind map for you guys. So first of all, extensive properties. Extensive properties only depend on the amount of matter that's there. It doesn't tell you what it is. You can't use it to identify the stuff. It just is telling you amount. So mass, volume, length, that's what extensive properties are. Intensive properties don't change no matter how much stuff you have. So mass can change with how much you have. It just depends on how much stuff you have, so it's an extensive property. Color isn't going to change with how much stuff you have. Density, it doesn't matter how much of the stuff you have. It's not going to change. You can have a lot of it and calculate the density, or you can have a little bit of it and calculate the density, and it doesn't change. Melting point, doesn't matter how much you have. Chocolate is going to melt at a certain temperature. Like Hershey's chocolate bar, it's going to melt at a certain temperature. It doesn't matter if you have a big chocolate bar or a small chocolate bar. It's going to have a certain melting point. Boiling point, freezing point, conductivity, all those are intensive properties, and they can be used to identify the stuff you have. So if you like those CSI shows and you talk about forensics, one of the tools that they can use to determine what substance, like they found this mysterious powder at a crime scene, they can use intensive properties to determine what that substance is. Density is a big one. Density is the mass of a substance per unit volume, or how much it weighs per given volume. Mass divided by volume. Density is intensive, and so it can be used for identification. Whenever you do the density problems, and you have a whole beautiful worksheet on density problems, you have to show your work, and that means write the equation, D is equal to M divided by V. Write the numbers in the equation, and put a box around your answer. Every single time, children, that's what you'll have to do. The units in the equation for density, mass has to be in grams, and volume should either be in milliliters or centimeters cubed, and if it's a gas, it'll be in liters. So let's focus on the milliliters or centimeters cubed. So you can have the density of a solid, it'll be in grams per centimeter cubed. You could put it in grams per mil, but you know, it's generally solids. We measure length times width times height in a lot of cases. So we think of it as centimeters cubed, length, centimeter times centimeter times centimeter, centimeter cubed. A lot of times we measure the liquid density, or we calculate the liquid density, and we have the mass still in grams, and we measure the volume in milliliters because we can pour it into a graduated cylinder. So our unit of measurement will be gram over milliliter. A centimeter cubed is the same as a milliliter. So they're interchangeable. You guys who are interested in nursing, or you are interested in some type of medicine, you'll notice that they talk about cc's, like 10 cc's of this medicine. cc is a cubic centimeter, which is the same as centimeter cubed. So cm cubed and cc that you hear on the hospital or see on a syringe is the same thing. Now, the last one is the density of a gas. And the gases are usually measured in grams per liter. That's just a general thing. When we start talking about the gas laws, we'll start talking about the density of gases. The only density that you have to memorize is the density of water, which is 1 gram per milliliter. That means if you have 1 gram of water, it's going to take up a volume of 1 milliliter, which is kind of cool. That's the basis, that's the control. We talked about the control being the normal. Water is like the control. It's the normal that everything else is compared to. Substances that are less dense than water will float. They'll be buoyant. Substances that are more dense than water, they have a density greater than 1, will sink down to the bottom. So density is kind of linked to that buoyancy thing too. So the closer the density is to that of the water, the lower in the water the object floats. So let's say you have a density of something and it's 0.8 grams per mil. Well, it's going to float on the water. But as let's say you have something that's a density of 0.97 grams per mil. It's going to float, it's going to stay up towards the top, but it'll be hanging low in the water there. Now, again, we have extensive or intensive. So the first one is boiling point. Boiling point is an intensive property because we can use it to identify what the substance is. Volume is just the amount of substance. It's extensive. We can't use it to identify something. Mass is the same way. It's extensive because it tells you how much something is, but it doesn't really tell you what it is or help you identify it. Density is intensive. different chemicals, different elements have different densities. And then conductivity, whether or not it conducts electricity, that's also intensive. Some things conduct electricity, some things don't. You guys all know that aluminum is going to conduct electricity. Metals, different types of metals conduct electricity. But does milk? So that conductivity is also an intensive property that can help you identify what the substance is that you're